All right, y'all, welcome back. This is what we are going to do for our 2.3 day one notes. So we're going to factor the GCF and when a does not equal 1. Now, you guys have already done this in Algebra 1. You did some of it in geometry. We'll see if you remember how to do it. Hopefully you do. We're going to start with the greatest common factor. So I'm going to give you a minute here to write down what the greatest common factor is. So the greatest common factor is the biggest number that is a factor of 2 or more terms. So basically, the number that goes into 2 or more things. Like, for example, if you had 4 and 6, the greatest common factor would be 2, because 2 goes into 4 and 2 goes into 6. And that's the biggest one that goes into it. If you had 16 and 8, right, the greatest common factor would be 8, because 8 goes into 8 and 8 goes into 16. You wouldn't pick 4. Now, 4 goes into 8 and 16. But it's not the greatest one. It's not the biggest one. Okay, so greatest means that it is the biggest one. All right. So we're going to do 3 or 4 examples of taking out the GCF, and then we're going to talk about how to factor when a does not equal 1. And I have a little bit of a different way of teaching it than you probably learned in the past, which I think hopefully will make your life a little bit easier and make it a little bit easier to understand. Okay. So feel free to pause it if you need to, but hopefully that was enough time to write that down. So these 4 examples, all we want to do is factor the GCF. So basically, if we start with this first one, 6x squared plus 18, okay, and you'll notice that these notes don't come from our workbook, so you're just going to have to write them down. Unfortunately, our workbook doesn't do a very good job with these kind of problems, okay? So factor out the GCF. So what we need to do is start with the numbers 6 and 18. Can you think of a number, the biggest number that goes into both 6 and 18? If you are stuck, if you don't know what multiplies to get 6 and you can't figure out what multiplies to get 18, I always just list them out. Multiplies to get 6 is 1, 2 times 3. So 2 times 3 and 1 times 6 will multiply to get me 6. What will multiply to get me 18? 1 and 18, obvi, hopefully. 2 and 9 will get me 18. And then 3 and 6 will also get me 18. So if you're ever stuck, just try to list everything that multiplies to get it, and then look for the biggest one that they have in common. In this case, they both have a 6 in common. So 6 is the biggest number that will go into both 6 and 18. Okay, so I'm going to take that 6 out, and I'm going to put it in front. Once I take it out, I have to divide these 2 terms by whatever I put in front. So 6 divided by 6 is 1. I didn't do anything to the x squared, so it just stays x squared. 18 divided by 6 is 3, so I'm going to put a 3, and we're finished. Right, so just look for whatever they have in common. Okay, sometimes they'll have variables in common, sometimes they won't. Like this one, no variables in common because this one doesn't have any x's. But this one, they are going to have a variable in common. Okay, so we're going to do the same thing. 7 and 14. Okay, again, if you are stuck, list them all out. Okay, some of you probably won't have to list them out, which is great. But what multiplies to get 7? That's just 1 and 7. And then what multiplies to get 14? That would be 1, 14, 2, and 7. This is a step you do not have to do. Okay, you do not have to list them out if you know it without doing it. Okay, so don't feel like you have to. And in this problem, if you look, they both have a 7. So they have a 7 in common. So that's what I'm going to take out. So start with the number 7. Once you do the numbers, then look at the variables. This one has 2 x's. This one has 1 x. Okay, that means they have 1 x in common. I couldn't take 2 x's out because this one only has 1. Right, so you always take out the lowest amount of variables. I know that sounds a little counterintuitive that we're looking for the greatest common factor, but the only one they have in common here is just one of those x's. Because again, if I tried to take out 2 from this one, I would be stuck. It only has 1. I can't take 2 away from 1. Okay, so then let's divide. 7 divided by 7 is 1. I had 2 x's. I took 1 away. That leaves me with just 1x. And you could write the 1 in front of the x if you wanted to. Doesn't matter. Doesn't change anything. 14 divided by 7 is 2. I had an x. I took the x away, so I don't have any left. There's our final answer. Okay? So start with the numbers, then go to the variables. All right, start with the numbers, then go to the variables. And you do this for every problem the rest of this chapter. We always look for the GCF, okay, first and foremost. All right, we're going to skip down to this fourth one, because this is the hardest one of the bunch that I have here. So start with the numbers, 11, 33, negative 121. Try to think of a number that goes into all three of those. All right, and again, you could list them out. If you were stuck, list them out. Okay, so I'll list them out in case you are stuck. What multiplies to get 11? That's just 1 and 11. What multiplies to get 33? That would be 1, 33. Or I could have 3 times 11. Those are the only things that will multiply to get us 33. What multiplies to get 121? 1, 121. 2 won't work. 3, and something. 30, 60, 90, that'd be 30. 37. 3 and 37. And then 11 times 11. 11 times 11 would get us 121. So then if we look, they all have an 11 in common. So that's what I'm going to take out of these three problems. Okay, I'm going to take an 11 out, and I'm going to put it in front. So once you are done with the numbers, then just look at the letters. This has 3 x's, this has 2 x's, this has 1 x. I have to take out the smallest amount that they have in common. So that's just going to be 1x. Again, I can't take 2 away because this only has 1. I can't take 3 away because neither of these have at least 3. Okay, so take out the smallest number and then just divide. 11 by 11 is 1. I had 3 x's, took 1 away, I'm left with x squared. 33 divided by 11 is 3. I had x squared, I took x out, that leaves 1x. 121 divided by 11 is 11. I had an x, took it out, no more x's left. There is our final answer. Okay, so take out whatever they have in common is what we're looking for. All right? And if you were confused on if you got it right, you could always multiply this back in, right? If you distributed that 11 back in, it should take you right back where you started. Right? So you can kind of check to see if you are right before you move on. Okay? All right. Here is the next thing we're going to talk about. Now we're going to factor when a does not equal 1. So I wrote out some steps here. Okay, so we are going to factor when a does not equal 1. So write down those steps for me really, really quickly. Okay, and you can pause it if you need to. But write out these steps, and then we're going to do a problem. Because once you do a problem, I think the steps will make sense. So if you write down these steps and you're like, holy crap, I'm so confused, don't worry. Okay, I'm going to give you, we're going to do 3 examples where you'll be able to see. Maybe 2, but hopefully 3 examples. Okay. So basically what we are going to do is we are going to multiply a times c. Now remember, a is always the first number in front of the x squared, and c is the thing that doesn't have a variable. Okay, normally it's the first number and the last number, but the order could be switched around. So it's whatever's in front of x squared times whatever doesn't have a variable. Okay, don't just get in the habit of doing first and last because it may not be first and last. Okay, we could switch it around on you. And it might try to confuse you. Okay, so if we did this first problem, 5x squared, the 5 is in front of the x squared, the 2 doesn't have a variable, so that's c. All right, what we are going to do is we are going to multiply a times c, and I make this big X, and most of you have probably seen this before. 5 times 2 is 10. That's what I put on top. The middle number, in this case 11, goes on the bottom. So what I need to do is find 2 numbers that multiply to get 10 and add to get 11. 2 numbers that multiply to get 10 but add to get 11. And if we thought about it, again, you could list out everything that multiplies to get 10, right? You have 1 and 10, or you have 2 and 5. That's the only things that multiply to get 10. Out of those options, the only ones that will add to get 11 are 1 and 10. And I always circle these numbers just so I remember those are the ones that I found. Right, I know where I'm looking. Once we find those numbers, so we did step 1. We did step 2. We found our numbers. Now we're on to step 3. Divide trinomial into 2 separate parentheses. I probably shouldn't have used the word divide. Basically, we're going to split this up into 2 separate parentheses. Okay? Whatever comes first in your problem, in this case 5, that's what I am going to put first in my parentheses. So you don't even have to think about it. If that was a 4x, I would put 4x here. If that was a 7x, I would put 7x here. Whatever comes first, you put first. Okay? Then, to finish off the parentheses, we are going to put the 2 numbers that we found. So I'm going to put +1 and I'm going to put +10 because they're both positive. Okay? So I'm almost done. We did step 3. We also did step 4. Fill in the a value. So we filled in a, which was 5x. And the 2 numbers you found in step 2, that was 1 and 10. The last step says divide each parentheses by the GCF. So now that you have this, look at each one of these and see if you can divide them by something. Like, do 5x and 1 have something in common? If you try to think of a number that goes into 5x and 1, you should hopefully get stuck because there's nothing. So they don't have anything in common. So that one's going to stay exactly the same. 5x plus 1 because there's nothing I can do. But this one, right, I could divide both of those by 5 because they have a 5 in common. If I divided them by 5, 5 divided by 5 is just 1x. 10 divided by 5 is 2. And we're finished. Sometimes you're going to have to divide both. Sometimes you're just going to divide one. Sometimes you won't be able to divide either of them. Okay, it just depends. And this is different than you probably learned in Algebra 1. Okay, this is a different method, but hopefully it makes it a little bit easier because we do the same steps every single time. Okay? And again, if you're stuck, you could multiply it back out. 5x times x, 5x times 2. 1 times x, 1 times 2. Okay? So you could multiply it back out. All right, let's try another example here. Let's do this one. 6x squared plus 13x plus 5. So the first number is not 1. It actually doesn't even matter. We're always going to do the same steps. So we are going to take a, which is in front of x squared, and c doesn't have a variable, and multiply them together. 6 times 5 is 30. And then what multiplies to get 13? So multiplies to get the top, adds to get the bottom. In this case, that would be 10 times 3. 10 times 3 is 30. 10 plus 3 is 13. Okay? So I found my numbers. That is step 2. Now I split this into 2 parentheses. And whatever comes first, in this case 6, that's what I'm going to put first. 6x and 6x. Then put the 2 numbers that you found, plus 10, plus 3. And now we're on the very last step. See if you can divide either one of these by something. Like 6 and 10 both have a 2 in common, so I could divide those by 2. If I divided those by 2, it would be 3x plus 5. These 2 have a 3 in common, so I could divide both of those by 3. 6 divided by 3 is 2x. 3 divided by 3 is 1, and we are finished. Okay, so again, whatever comes first, put that first in the parentheses. All right, that's the one thing that you might forget. Okay, and then divide them out. All right, we're going to do one more, and then I'll quit talking to you, even though my voice, I'm sure, is really soothing to you right now. Okay, 3x squared plus 4x minus 15. We have a in front of x squared. We have c without a variable. All right, so we make our big X. 3 times negative 15 now is negative 45, and we need it to add to give us 4. So we have to try to think about what would multiply to get negative 45, but what would add to give us 4. If we thought about it, if we went through our numbers, we hopefully would end up at 9 times negative 5. 9 times negative 5 would get us negative 45. 9 minus 5 is 4. Positive 4, so it works. Okay, so now we take that problem, split it up, just like before. 3x squared came first, so I put 3x and 3x. Right? I don't even have to think about it. Whatever's first, I put first. Then I plug in my numbers, plus 9, minus 5. And then I look to see if I can divide. 3 and 9, I could divide them both by 3. 3 and 5, I can't divide by anything. So this second one's not going to change at all. So the first one, 3 divided by 3 is just 1x. 9 divided by 3 is 3. And the second one isn't changing, 3x minus 5. And there you go. That is our 2.3 day 1 notes when factoring when A is not 1 and the GCF. Hopefully it makes sense. If you have any questions, please don't be shy. Reach out to me. I will be more than happy to help you. And that's it. Thank you all very much. Deuces.